That's something about exploring the polynomial identities. And we're going to first look at, just to kind of remind us of how things worked, look at a couple of things we did last chapter. So multiplying out a binomial or factoring a binomial. So why don't you take a few minutes and factor these or multiply them out. Remember that you have access to using the box to assist you with this. And we can either, like on the first one, we can do A and keep 3, A and a 3, and then you multiply it out. So looking at problem number 1, we want to take and multiply this set out. And so when we multiply it, we get a squared, 3a, and 9. Combine it together, we get a squared plus 6a plus 9. And last chapter we talked about, the shortcut for factoring this type of trinomial when you can take the square root of the first and the square root of the last. And if you multiplied those and doubled it, and it was the middle term, then you could shortcut it and go to the a plus 3 squared. Well, the same thing works to go the reverse way. So you square the first, square the second, and double the product. And so it would be a squared plus 6a plus 9. Well, this one was a binomial. And we could take the square root of a squared, and that gives you a. And you could take the square root of 25, and that gave you a 5, which means I could factor it into a plus 5, a minus 5. And so again, we have a binomial that's squaring, so we can square the first, double the product. So the product is 8a, so doubling that is 16, and we take this middle sign over. And then 8 squared is 64. So that's your answer. And so we're going to use these, and it was easier for us to think about them when we had letters with it and numbers than it is when we straight out have letters. Now let me go over one more, just so we can remember x minus 27. Oh, x cubed minus 27. If I wanted to factor that, well, I could take the cube root of x cubed, and I come up with x. The cube root of 27, and I would come up with 3. And so I would have x minus 3, and the second parenthesis would be x squared, then the product of 3x, and we do opposite sign, and then 9. So what we're going to do is we're going to go through this list, A through G, and we're going to either factor it or multiply it out. I'm going to do A and D with you right now, and then you will do the rest. The only things that we can use are from this list. And so you're going to find out what would the factors be that would create it. Well, A plus B, if I was to go over and use a box, I could, and I would come up with a squared plus 2ab plus b squared. And so that is the factor that's used for a, or the expression that's used for a. So we're trying to write the equivalent expression of a plus b, that quantity cubed. Well, I can think about it as a plus b times a plus b squared. So a plus b times, we've already found that up here, and that was a squared plus 2ab plus b squared. So I want you to find the factors that would create these other 5, and then check them off as you go through them on the questions. Check your work here and see which ones you need to correct. So when we're looking at the relationships you wrote in question 1, what we did to help us calculate the a plus b cubed is we split it apart into a plus b times a plus b squared to be able to work with. Versus when we needed to factor, we use the difference of squares, difference of cubes, or sum of cubes. So we have Zach, and he says that if we have the expression a plus b and we square it, it's going to be the same thing as if we have the expression a minus b and we square it. But Meg says, no, that's not true, because we found out their equivalent expression. Their equivalent expression said that we had a squared minus 2ab plus b squared. So that can't equal a squared plus 2ab plus b squared. And so let's kind of look at something. Let's just choose 2 random numbers. I'm going to choose 3 and 1 and see what it means. So 3 plus 1 squared, does that equal 3 minus 1 squared? So 4 squared doesn't equal 2 squared, and so therefore it's not coming out as true. And you can see it even over here. We have 3 squared minus 2 times 3 times 1 is plus b squared. And we see that it's not equal to 3 squared plus 2 times 3 times 1 plus 1 squared. So 9 minus 6 plus 1 is not the same thing as 9 plus 6 plus 1. So Meg is right. And so when we're working at calculating these polynomial identities, a lot of what these come back to is they help us as we're trying to calculate. And if we remember that not always have we actually had access to a calculator at all times. It's a relatively new invention. My teachers used to tell us, you'll never carry around a calculator in your pocket. Within a few years, we all have calculators in our pockets. But it helps us just kind of see how to mentally do a little bit of things with math shorter. And so I'm going to go ahead and teach you this process. It's a lot of mental math shortcuts. When you're writing out mental math shortcuts, it does seem like it's longer. But just realize that they are meant to be the things that you do mentally. So I'm going to go ahead and find the 46 squared without using my calculator. And so step 1 is I'm going to find what 2 things can I add together to create 46. So I did 40 and 6. Because I can square 40 pretty easy, and I can square 6 very easily. And so I'm going to square those 2 things. And so remember that the shortcut said that if I have a plus b squared, I square the first, double their product, square the last. And so I'm going to kind of show you what it would look like if I was actually write it out, what's going on. But honestly, when I do this myself, I just go ahead and go straight to writing the number. I'm just showing you what's in my head of what I'm doing math-wise. And so 40 squared, I take 4 squared, that gives me 16, and then I double my zeros. Plus 2 times 40, 80, times 6 is 480, plus 36. Now I add all these together and I get 6, 1, carry my 1, and then I add 3 plus 1 plus 4 to 6, and that gives me 14. Carry the 1. Oh, no, wait a minute, not 3 plus. Got off my spots. 4 plus 6 plus that 1 gives me 11. Carry my 1 gives me 2,116. But honestly on this isn't the easiest way. I can actually find 46 an easier way by subtracting 4 from it. And so I would have 50 squared minus 2 times 4 times 50 plus 4 squared. So 2 squared, or 5 squared is 25, and doubling my zeros gives me 2 zeros. If I was to multiply this all together, 2 times 50 is 100, times the 4, which is 400. So 2,500 minus 400 is 2100 plus 16. And so that gives me 2116. And again, I'm showing you the processes that I'm doing in my head, but that doesn't mean that you have to write them all down. I usually just write down the step where I actually show my math, just so I can make sure I don't get off on my placeholders. So if we look at this next one, 112 squared. What two things can add up to be 112? To me, I thought about 112. And when I did that, I came up with 100 squared plus 2 times 100 times 12. That's 12 squared. I can find 12 squared relatively easy, so that's going to be 144. 2 times 12 is 24. Tack on 2 zeros. 100 squared is double the zeros and square the first. So when I add all these together, I end up with 44 is my ending, the 5, and then 12. So 27 cubed, the way I thought about it was 30 minus 3 cubed. So 30 minus 3 times 30 minus 3 squared. And so I'm just going to leave that as 30 minus 3. 30 squared minus 2 times 3 times 30 minus or plus 3 squared. Now I'm going to distribute that through to each piece. Actually, I'll go ahead and rewrite that just because I think it's going to make it easier for us to see what I'm doing, where I'm pulling numbers from. 900 minus 6 times 3 is 180 plus 9. And so you can simplify this down and then multiply it times 33, or we can take and use some of our properties that we know work. So I can distribute 3 to all 3 parts. So 3 times 900 is 2,700. 3 times 18 is 540 plus 9. Okay, so that gives us all the 3's being multiplied in. Oops, this must be a 9. Now I'm going to do the same thing, but I'm going to go ahead and use my 30's. So 900 times 30 is 27. Now I have 3 zeros. Minus 30 times 180. And 30 times 9 is 27. Thousand. Oh, that's right. That's where I messed up here. I'm doing 30 times. I is negative 27. And they're opposite sides, so it's multiplying in negative 3. Now let's combine like terms. Oops, way too many zeros there. And so that became 2187. 2,700, 27,000 minus 5,400 plus 2,700. Or 270. Equals 21,870. So when we add those two together, we end up with a total of, oh, my pen went away. $24,057. And so it's not always easier, or it's not always easy, but it is easier than multiplying 27 cubed, or 27 times itself 3 times. Same idea on this one. Except for this one to me is easier because it's working with 5s. So 50 plus 5 cubed. So 50 plus 5. I want you to think through, how could you do 112 squared what are the two different things we could add or subtract to get 112? What? 120 minus 8?
You go 100 plus 12.
That's the way I went, was 100 plus 12. But 120 minus 8 is not, which way would y'all rather work?
It doesn't matter.
Let's do both. Just kind of see how it looks. So 100 squared plus double the product plus 12 squared. So 1 with double the zeros, because 1 squared is 1. 200 times 12, 2400, plus 144. So that 44. 1 plus 4 is 5. And then 12. On this one, we had 120 squared minus 2 times 120 times 8 plus 8 squared. And so if we do 8 times 12, that would be 16, carry 1, so 96 times 2, which is not 2,000. We're 80 short of 2,000, so 190, 1920. Plus 64, and this is 144 with 2 zeros. So we subtract, and so that makes this a 13, makes this a 13, a 9, and a 10, or a 10, excuse me. And so we have 80, 4, 12, 8, 480 plus 64, which gives you 12, 5, 44. And so it really kind of depends on how you think, is which one will be easier. Now, I'm not going to lie, anything when you're doing it to the third power is challenging. It doesn't matter if you're doing 27 times 27, get that number and then multiply that answer times 27. That's going to be a challenging process. Or if you're doing it through this shortcut. It's not going to be, there is no easy to it, there's just an easier. Does that make sense? So I think about 27 as 30 minus 3 cubed, which is 30 minus 3 times, what's 30 squared? Three times 3 is 9. Double the zeros. Doubling their product. So that's 90 times 2, so 180. Plus 127. Come on, let's go ahead a step. 9. So instead of going ahead and multiplying this as 27, we're going to go ahead and leave it separated in that first parenthesis, and we're going to do a double distribution. And I want to show it with the green and the yellow here in a second. So like when I distribute the green, which is going to be that 30 through to all of them, 30 times 900. 30 times 9 is 27. And then count up my zeros. 30 times 18, or excuse me, 30 times 180. And so if I do 3 times 18, gives me a 24. Carry the 2, 540. And there's 2 zeros. 30 times 9 is 27 with a 0. So now I'm going to take and do my -3. What's 3 times 9? $27, right? What's 3 times 180? Well, you already found out 3 times 18 is 54. And 1 0. What's 3 times 900? $2,700. And you see how I just kind of line those up in their second columns? And that kind of keeps things where it's lined up a little easier, and it may make it easier for you to combine like terms. So I know that last thing is going to be, we're going to be subtracting that 27 at the end. So let's combine all of my negatives. And so I know it ends in a 27. 7 and 4 is 11. Carry, and that would be 8. Add up my positives. Well, I have these two positives, 270 and 540. 7 and 4 is 11. And then we have our 8 and then 27. That's going to be a 3 at the end. And that would be a 8, 6, excuse me, 17. And so whether you think that's easier than multiplying 27 times 27 times 27, I don't know. But it's just a different way of getting there. When it's 5s, it's definitely a lot easier. Because multiplying by 5s is relatively easy, right? By comparison. So I thought of this as 50 plus 5. Plus we're adding here instead of subtracting. And so we're going to write 50 plus 5 and 50 squared plus 2 times 50 times 5 plus 5 squared. So again, we're just leaving this out like it is. 5 squared is double my zeros. 2 times 50 is 100 times 5, so 500 plus 25. And honestly, on this one, you could either add it all together and get the 3025 and then multiply it to each part, or you could take and distribute it through. Which way do you want to go? Where we do the 50 to each of these and the 5 to each of these, Or do you want to think of it as, because we're working with fives, which one do you think will be easier? Which one do you want to go with? So just realize you don't always have to keep it all expanded. Sometimes it's easier to keep it all expanded, like when we're multiplying some of these. When we combined it together, it may have been more challenging to multiply by 30 and 3. But not always. Sometimes it's just as easy to go ahead and combine it. So 5 times 5 is 25. Carry the 2. 2 times 5 is 10 plus the 2. Carry the 1. 5 times 3 is 15. Now we're going to add to that 50 times. So when I do 50 times, I'm going to put a 0. And it's going to be 5 times the other number. So we've already got that number found. Oops. And so when we add it, it becomes that. So that's the same thing as if I went over here and multiply 55 times 5. And then find that answer and multiply it times 55. You see how this is a lot shorter? It really kind of depends on the numbers. Sometimes longhand is just going to be the easiest way. But especially if you can get it estimated near numbers that are easy to work with, then it's really kind of nice. So back in geometry, we learned about Pythagorean theorem, where we said A, B, C, and C is the hypotenuse. And then your teacher is like, oh, by the way, after we did all these, there's a shortcut for some of them, right? If you had 3, 4, and 5, you always knew they were there. So if you had a 3 and a 5, you knew the one was 4. 5, 12, and 13 were another set of triples. And they called it a Pythagorean triple. And they probably said there are more of them out there. And they probably left it at that. They may have shown you a couple of other examples of it, but they probably didn't go in too deep. And that's because to find them, we're going to use Euclid's formula. But before we get there, let's just practice with finding out which of these are Pythagorean triples. So our C is always our biggest number. So what's my C in number A? Or letter A? So 9 squared. The other two, it doesn't really matter the order. 4 squared is? Plus 5 squared is? Equals 9 squared, which is? So if I add these together, I come up with 41. Does that equal 81? No. So it's not a triple. I want you to do B and C.